Today we're going to look at graphing linear inequalities. So before we can start graphing them, we have to make sure we understand when we have a solution and when we don't have a solution for one of these linear inequalities. So looking at problem 1, we have a point 1, 2. We're going to take that point and plug it into the x and the y of the inequality. So we'll have 9 1 minus 4 2 less than 20. From there, 9 times 1 is 9, 4 times 2 is 8, and so 9 minus 8 is going to give us 1. Is 1 less than 20? The answer is yes. Well, if you have a yes, then the point 1, 2 is a solution. Now, if we look at problem 2, we plug in x for 0, and we're going to plug in 0 in for y. We have 0 go right here. 7 over 2 times 0 plus 2. Well, 7 over 2 times 0 is just 0. And 0 plus 2 is 2. Is 0 greater than or equal to 2? The answer is no. So 0, 0 is not a solution. So this is how you can tell if something is a solution or not. You plug the point in, and if it makes sense when you read it, it's a solution. If it doesn't make any sense, then it's not a solution. So let's take a look at figuring out what does it look like as a graph, and what do the points mean when you look at the graph. So we have this inequality, y is greater than or equal to negative 2 over 5x minus 1. Below it is the actual graph of this inequality. And I've chosen 2 points. I've chosen the point negative 2, negative 5, negative 2, this one right here. And I've chosen the point 0, 0. And I need to figure out which one is actually a solution to this inequality. So if I take the point negative 5, negative 2, and I plug it in, so I have negative 2 for the y, negative 2 over 5, my x is negative 5, and I'm going to do the math. Negative 2 times negative 5 is positive 10. 10 divided by 5 is 2. 2 take away 1 is 1. And so we ask the question, is negative 2 greater than or equal to 1? No, it's not. Therefore, we know that this point is not a solution. So that guy is not a solution. I'm going to go ahead and check the point 0, 0. So once again, 0 for x, 0 for y. I'll have 0 is greater than or equal to negative 2 over 5 times 0 minus 1. Negative 2 over 5 times 0 is just 0. 0 minus 1 is negative 1. Is 0 greater than or equal to negative 1? Yes. Therefore, 0, 0 is a solution. That means this point right here is a solution. Now that point was above the line. That means if you plug in the point negative 1, 1, that would also be a solution. Same thing with 2, 2, 3, 1. This point, 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 this point. All the points in the shaded area would give you yes if you plug those points into the inequality. Below the line, you see it's not shaded. That would be like the point negative 5, negative 2. Those points would not be solutions. That's why they're not shaded. Inequalities have millions upon millions of answers. We have to use shaded areas to represent those points because we can't plot all of them. All right, let's take a look at this one. We're only going to look at one point this time. You'll notice this time the inequality has a dashed line. We're going to go ahead and figure out what does the dashed line really mean in relationship to a point. So we have a point -2, 2. It's this point right here on the dashed line. I'm going to go ahead and I'm going to plug that point in, and I want to see what kind of answer I get. So my x is -2, my y is +2. I'm going to have 2 is greater than -1 over 2 times -2 plus 1. So I have -1 times -2, that's +2 over 2. Now 2 divided by 2 gives me 1. 1 plus 1 is 2. Is 2 greater than 2? No. So the point on the dashed line is not a solution. None of the points on the dashed line will be a solution. So therefore, this line right here that we have, this dashed line, there are no answers on the dashed line. However, you'll notice there's a shaded area above it. All the answers are above the dashed line. We call this dashed line a boundary line. We draw it so we know where we can shade, so therefore we know where the answers are. But if it's a dashed line, the answer is not on the line at all. No answers are on the line. Okay, this one, we're going to take a look at a solid line, and what does it mean? We're going to take the point 5, -1, and we're going to plug it into our inequality. So -1 for the y, 5 in for the x, 1 times 5 is 5, 5 divided by 5 is 1, 1 take away 2 is -1. So we asked ourselves, is -1 greater than -1? No, but is -1 equal to -1? Yes. Therefore, it's a solution. That means this boundary line has answers on its line. So every point on this line and all the shaded region is going to be solutions. Now that you've seen where things are solutions and where things are not solutions, we need to go ahead and actually go through how do you graph an inequality. Well, we have y is less than -2x plus 1. We're going to go ahead and graph this. The 1 is our y-intercept. Our -2 is really -2 over 1. That's our slope. So we're going to go ahead and go down 2 and right 1. So I'm going to go ahead and graph that. I'm going to start a point at 1 on the y-axis. And then I'm going to count down 2 and right 1. Down 2, right 1. Down 2, right 1. I'm going to keep doing that pattern. And then up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1. Now this is where we have to decide, should we be having a solid line or a dashed line? Well, the way you can tell is if you have a less than sign or a greater than sign, it's going to be a dashed line. This means the points that you just plotted aren't answers. They are there just to help us make that boundary line so we can figure out where to shade. Well, we're not done. We know that since we have a dashed line, there's no answers on that line. We have to create a shaded region. To do that, you're going to pick a point. You're going to figure out if that point is a solution or not. If you find that point is a solution, every point on that side of the line is also a solution. I like to pick the point 0, 0. And I like to check that one. So I'm going to have my x be 0 and my y be 0. I'm going to go ahead and plug it in. 0 is less than -2 times 0 plus 1. -2 times 0 is 0. 0 plus 1 is 1. So now the question is 0 less than 1? Yes. that means the point right here was a solution. That means this point's a solution, this point's a solution, this point's a solution, this one's a solution, this one's a solution, this one's a solution. Everything to the left of that dashed line is a solution. So the way we do it, we just go ahead and do a little shade on that side of the dashed line to represent all the solutions. So please remember, if you have a less than sign or a greater than sign, those are the dashed lines, and there is no answers on the dashed line, only to the left or to the right of it. All right, our last problem. So we have y is greater than or equal to 2 over 3x plus 4. We're going to go ahead and graph that out. We have our y-intercept at 4, and we have 2 over 3 for our slope. It's positive, so up 2 to the right 3. Going to start at 4 on the y-axis. Going to go up 2 and right 3, up 2 and right 3. Going to continue that, going the other way, down to left 3, down to left 3, down to left 3. Now this time, if you have a greater than or equal to, or a less than or equal to, you're going to have yourself a solid line. So I'm going to connect all the points, and all the points on that line are solutions, but we also have to find the points that are solutions in the shaded region. We got to create a shaded region here. So once again, I recommend you pick a point, 0, 0. We're going to check 0, 0. So our x is 0, our y is 0. So we're going to have 0 is greater than or equal to 2 over 3 times 0 plus 4. Well, 2/3 times 0 is 0. 0 plus 4 is 4. Is 0 greater than or equal to 4? No. So if 0, 0 was right here, that's a no. That means all the correct answers have to be on the other side. So I'm going to go ahead and do a shaded area above the line. Because if 0, 0 wasn't an answer, that means none of the points below that red line are going to be answers. So all the answers must be above it. If you're having any trouble, go back and watch certain portions of this video until you get it.